Okay, so far we were discussing on RL part, right? So now it is going to be RC. So you would have come across some, you would have had some ideas on how this is going to be, correct? ஏன்னா நம்ம அதுக்கு முன்னாடி வந்து இண்டக்டர் தனியா பார்க்கும்போது we were discussing that the current is going to lag the EMF by 90 degrees. But இங்க வந்து கெபாசிட்டர்னு பார்க்கும்போது என்னவா இருக்கும்? Lead by 90 degree, but ana the individual capacitor anda okay, but ana you are going to have the combination of resistor and the capacitor, correct? Okay, so again this EMF is going to be splitted into the potential drop across the resistor and the capacitor. So can I take this as V naught R and this is going to be V naught C, right? So in this case the potential is going to be in phase with the current, but in this case lagging by 90 degrees, correct? Yes, this is what is the phase, right? So again V naught R will be equal to I naught times R and V naught C will be equal to I naught times XC. So can we go for phasor diagram? Again, so the resistor combination, so V naught R, right? And the current is going to be in phase with this I naught, right? And now the current is going to lead the voltage by 90 degrees. So obviously this will be V naught C, correct? So the resultant will be in between these two, but always keep in mind they cannot be negative. Apo okay, so this is going to be what? Omega t, and this is going to be phi, this is going to be together omega t plus phi. Again there is going to be a right angle triangle which we can evaluate, right? So now by using Pythagoras theorem, again E naught square will be equal to V naught R the whole square plus V naught C the whole square, correct? So what is V naught R? I naught R the whole square plus I naught XC the whole square. So I naught square taking common, R square plus XC square is going to be E naught square. I want I naught square, so E naught square divided by R square plus XC square. So you will be having E naught divided by root of R square plus XC square. Yes. So also you can replace this with I naught is equal to E naught divided by root of R square plus 1 by omega C the whole square. So you know it as XC is equal to 1 by omega C. So you get that equation. Is that clear? So far okay, right? So now what we have to do? Again, what is this XC? It is capacitive reactance. So together this entire equation is going to be impedance. The combination of resistor plus reactance is nothing but impedance. It can be either capacitive reactance or inductive reactance or all two together. Okay, so it is going to be called as impedance only, right? Fine. So now this equation can be rewritten like I naught is equal to E naught by Z. Is that clear? Right? So do you have any doubts in this? No? Right. Again, so E is equal to E naught sin omega t was the input and the output was what? Plus phi. Yes or no? So you can see this is nothing but what? Omega t plus phi. So that is what is the current's value. So we can say that the current leads EMF by phi, correct? Yes, in that case for an RL circuit it lagged. Is that clear? Right? So from these two circuits what we come into a conclusion is if a resistor is combined with an inductor or with an capacitor, there will be phase difference, correct? And also the phase difference is going to be the factor which is decided by the component which is being connected. If the resistor is combined with inductor, the current is going to lag the EMF by phase angle phi. If the resistor is going to be combined with the capacitor, right? So the current is going to lead the EMF by phase angle phi. Is that clear? So the phase difference is decided by the component which is being connected along with the resistor. Clear? Is that clear? Yes? Okay. So far we were discussing on R, L, C, RL, RC. Now we are going to enter into all the form of combination RLC or LCR.